Okay, Superhero Supplies Incorporated makes a tall, building leaping superpower soup. In the equation below, T is the number of time in seconds, and V is the number of liters in the soup in the vat at the factory. So it's liters of soup. And we're trying to calculate how many liters of soup are in the vat at any given time. So when we look at the table, we're going to have time in seconds. So here we have 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, right? Now, after 0 seconds, all you have is 2. Where do we see that? Right here, right? That plus 2 means that whatever else happened, the vat started with 2 liters in it. So after 0 seconds, it has that 2 liters there, right? After 1 second, it's poured out 4, right? You see that 4, which stands for the rate of liters per second, right? Because if you can tell, because it's 4 times the seconds. So that means that for every 1 second, it's 4 liters are coming out. That's the ratio part of this equation, of this expression, right? This expression, this equation. It's actually, well, whatever. Okay, so you've got 1 here, and if you multiply 1 times 4, that's 4. You add the 2, you get 6, right? Then you have the 2, right? You take the 2 times the 4, add the 2, you get 10, right? You take the blue, let's see, you take the 3, you multiply that by the 4, right? Put that in for the t, you multiply it by the 4, add the 2, and you get 14 right here, right? You take the 4, multiply it by the 4, right? 4 is the t, put the t in next to the 4, 4 times 4 is 16, add 2, that's 18. Okay, so that is the answer to number 1. Okay, over here it says plot the points from the table, connect the points if it makes sense to. Now, what they're saying here is you want to plot the points, this going on the x-axis, this going on the y-axis, right? Here's your x, here's your y, right? So at x, 0, that's this 0 right here. The y is 2, which is this 2 right here, and so we put a point. Right? At x1, the y is at 6. At x2, the y is at 10. And so on, etc. Now again, what they're saying is when they connects the point, if it makes sense to. If it says makes sense to, they're talking about if it's a straight line. And if it's a straight line, it means that you can draw a rate triangle, right? And it has a fixed ratio, right? So our expression and our table and our graph are all talking about this fixed ratio of 4 seconds, of 4 liters per 1 second, which is what is reflected in the 4t. It's that rate, that constant rate, which we've talked about before. The plus 2 is just something that is added on to this particular equation, and it does not change that. It just moves the whole line up 2, right? If it was that 2 wasn't there, the line would be down here. That's a terrible reflection of that line. Let's do that again, right? It'd be the same line all the way up. It'd just be 2 points lower all the way, right? And that's just because there were 2 liters to start with. And that's the only thing that that 2 up here means. And they are actually going to tell you about that in the next part of the equation. Okay, so here is the soup flowing at a constant rate? Explain how you found your answer.
Hey,
Okay, we were interrupted for a moment there. So here we go. Yes, is it flowing at a constant rate? You can tell that by the line, or you can say when you were comparing, when you drew the rate triangle, you could see that it was going up at a constant rate of 4 per second. So what does the 4 in V equals 4t plus 2 tell you? 4t, that 4 is the rate, right? It's because that's the relationship per second, right? T is the time in seconds, so it's 4 every second, so it's literally your rate. So when you're writing it as an expression, that is what a constant rate looks like, right? And what does the 2 in this it tell you? It tells you the vat had 2 liters to start with. Anytime you're adding. And that was that.
What are we doing in the next minute?
Okay, so here we go. For every $10 Josephine earns, she spends 8. So that's a ratio of 10 per, or 8 per 10. Right? So if she spends 35, take, this is 35, this is 28, right? So it's 3.5. If you have tens, 35 is 3.5 tens, 3.5 eighths is 28. It's that simple. There's a lot of ways to make it more complicated. Sari is covering the top, bottom, and sides of the jewelry box with cloth. The top and bottom of the box are regular octagons. Write an expression that you can use to find the number of square inches that she needs to use. Then use the expression to find the answer. So you set the problem up. They do 2 times 5 times 4 divided by 2. So, and then multiply that by 8. So we have, in here, we have this little triangle that is 4 along the base and 5, right, tall. 5 times 4 is 20. Divide that by 2 over here, and that will give you the area for this whole triangle. There is one triangle for every side, so you multiply it by 8. And then you add to that, right, 8 times 4 times 8. Here they're noticing that you have on each side connecting this prism 4 inches plus, right, 8 inches on this one side, 4 inches on this side. 4 times 8 would give you the whole area in here. Okay, and then you add, so then you multiply those two together, and then you multiply that number by 1 for each one of the sides. And then you add in the sides, and then you add in the top and the bottom that you figured out with the triangles, and you get 416 inches squared. All right. Okay. Now we're looking at the distributive property. Basically what the distributive property says is that if you have 3 numbers, right, any 3 numbers like these, you can multiply them by one thing, right, by this 4, and then add them together, or you can add them together first and then do the multiplication. So if I wanted to go ahead and multiply them, if you want to multiply them, right, each one, it's 4 times 36. 4 times 9 is 46m. 4 times 6 is 24b, right? And then 4 times 4 is 16. And the r is outside the parentheses, so it's just hanging out. Now we take this guy, right? Because these 3 obviously have a relationship, and this one obviously doesn't. These are all multiples of 2. This one isn't. And if you look carefully, you can see that in addition to the 2, we also have a t in each one, right? So you take 2t out, right? What times 2t would give you 8tr? And the answer is that would be 4r. what times 2t would give you 10t, and the answer is 5. What times 2t would be would give you 14t squared, and the answer is 7t. 7t, not 70, right? And then once again, 13 is just hanging out because it wasn't part of the original. It wasn't part of that parentheses. Now then, you can also just subdivide one equation again. Here you can see these two numbers have a relationship, right? So you take out the 2. What times 2 would give you 2t? And the answer is, of course, just t. Subtract from that. What times 2 would give you 10r? And the answer is 5r, right? And here we do the same thing again with just a small part of this expression. If I take 2x times 5y, I get 10xy. If I take 2x times 12, I get 24x. And in this way, you can either isolate variables, right? Isolate these variables, or include them in the equation, depending on what it is you need to do. All right, one last one. Craft Store sells 2 t-shirts for $11. Complete the table to show the cost of the shirts. Write an equation relating to the number of shirts N and the total cost in dollars T, right? So they figured out what the unit rate would be, right? They took 2 and divided it by 2 and got 1 to get the 1. So then they took the price for 2, divided that also by 2, and got $5.50, right? So how much does it cost to buy the shirts? Here's your unit rate, right? This is what a unit rate looks like in an expression, unit rate or constant rate, right? Anyway, either way, they're just both examples of ratios. This is what it looks like as an expression, right? Once we have that, we can plug in things, so plug in whatever we need. So for instance, here we have 15 shirts, so we take 5.5 and we multiply that by the 15. And that gives you $82.50. All right. Stretch your thinking. No one ever does. If you do, come see me.